Hi there and welcome to this video for Senior Physics on Light and Waves. In this video we're going to explore the eye and how lenses can be utilised to correct eye problems. So let's just give an overview of what the eye is. Well, basically an eye is a simple receptor. All it does, or the job of it, is literally to take in light, different types of light which are being reflected off different surfaces. That light is then focused onto a screen, the screen being retina at the back of our eye. It's converted into an electrical signal, and then that electrical signal is sent via the optic nerve to the brain. The brain then interprets these electrical signals as the vision that we see today. So often I have quite a lot of fun with my students and I say to them, how do we see? And everyone says, when we see with our eyes. We look with our eyes. Well, actually, all the eye does is take in that light. We actually see with our brain because our brain interprets the electrical signal. So when you see an image, it's not here that you actually see the image. It's up here, inside your brain, in the light centers of your brain, which processes all that light information. Now, the eye, basically is a gelatinous blob. It's got fluid on the inside, it's got a jelly-like lens, and it's got a protective coating. That protective coating is called the cornea. Now, the fluid, the cornea, and the lens all have a job of refracting the light onto that retina, that screen at the back of your eye. Okay, so all of those things will bend the light, and we can alter the position of our lens as it passes through the fluid so that we can continuously get a clear image on our retina, so that we get a clear image in our brain. Okay, so obviously that's fine if your eye is working correctly. The trouble is, not all the time does our eye work correctly. Now, if you imagine the lens itself is held by what we call suspensory ligaments, which then are held by muscles around the outside. And by contracting and relaxing those muscles, we contract or relax the ligaments, which pulls the lens long and thin or allows the lens to go short and fat. Obviously, by pulling it long and thin, there's less bending of the light, there's less refraction. If we actually make it shorter and fatter, then we can actually bend the light a lot more, so there's more refraction. Now, this is very, very important when we look at problems with the eye. Now, there are two main types of eyesight correction that we have. There's short-sightedness, myopia, or there's long-sightedness, which is hyperopia. Now, with myopia or short-sightedness, the lens remains short and fat. You can't pull it long and thin. Now, this is great if you're reading up close. If you're reading up nice and close, you actually want to bend the light which is coming off the page onto your retina. So short and fat causes a lot of bending, which is great. You look at an object from far away, your lens doesn't change, which means that any object far away that doesn't require a huge amount of bending of light is bent very, very severely. And the result is, as you can see in the picture here, the image basically is formed, i.e. where the rays converge before they hit the retina, which means on the retina where the light-sensitive cells are, what you've actually got is a blurred image. Hence, when you look at an object and you look closely at an object from far away, you're going to see a blurred image, and the result is you're not going to be able to make it out. So we need to have some form of correction to prevent that converged image forming in front of the retina. We want it to form bang on the retina. Okay, now long-sightedness or hyperopia is where the lens remains long and thin. From a long distance away you can see, hence you're long-sighted, because you only need to bend light a small amount because it's already being bent as it moves through the air. So the light basically only needs a small amount of bending, which is great. When you look at something up close where you want it to be bent a huge amount, it doesn't happen. You only get it bent a small amount, which means that the image is formed behind the eye. Again, you can see in the picture here that the eye chart is actually forming where the rays converge behind the retina, which means that you've got a large area where the cells are stimulated. With that large amount of stimulation of those cells, what we're going to get is again a blurred image. So again, what we want to do is to pull that image from the back of our eye onto the retina, or from behind the eye onto the retina, so that we can actually get a nice, clear, crisp, sharp image. So short-sightedness, long and fat, you can't go long and thin. Long-sightedness, long and thin, you can't go short and fat. So how do we correct, or how do optometrists correct this using lenses? Well, for short-sightedness, remember, we're bending it a huge amount. Now, when you're looking at something far away, what you actually want to do is to prevent that large amount of bending. So in this case, what we use is a concave lens. Now, the concave lens has the effect of diverging the rays. Now, by diverging the rays out, when it hits the lens of the eye, it can then pull it back in. And what will happen is your eyes will be tested to see how much it needs to be diverged out before it can be pulled in, which is directly related to your lens. So let's have a look at a quick diagram. So here we've got our light rays. I've got 3 light rays coming in, okay, at point 1. They're going to hit the lens. Now, prior to putting that lens in front, remember what will happen is the lens of the eye will actually cause the image to form in front of the retina. Note that we want them to converge on the arrowhead of that second line. So what happens when you put the concave lens in, the concave lens causes the rays to diverge outwards. So they're making them further apart. By making them further apart, the result is that the lens will use its short and fattedness, if you pardon the word, to actually bend it back in. So you can see in section 2 here, we're opening the rays outwards. Now it's going to hit the lens. Now the lens won't change, which means that it's going to remain short and fat, but because the rays are wide apart, the bending will actually cause it to come back in so that we get an image which is formed where they cross on that arrowhead at the back of the eye. Okay, so for short-sightedness or myopia, we use a concave lens, a diverging lens, which opens the rays out so that when it hits the lens of the eye, it can be pulled back in. Now for long-sightedness, we need the other one. Remember, the lens in this case is going to be long and thin. It can't bend light a lot. So we need to help it bending that light in when we're looking at a close-up object. So in this case, we use a convex lens. So just as before, you can see the light coming in. It's close up, so the rays are far apart in one. Now remember, we want to actually get them to converge on the arrowhead of that second line. Now with long-sightedness, that won't happen because the lens is too short, long and thin, so the image normally is formed behind the eye. So what we're going to use, that convex lens is going to bend that light in. It's going to help the lens. So you can see here in section 2, it's bending the light in, and then when it hits that long and thin lens, which can only bend light a little bit, remember it's already been pulled in a little bit by the glasses. The result is they will pull it in enough so that the image will be formed clearly on the retina screen. Okay, so obviously an optometrist will determine the degree with which your lens needs help, and as a result, you will vary the sizes of your lenses. Sometimes the lenses are, very, very thin because it doesn't need to do a lot of work. Sometimes they're really, really fat because they need to do a huge amount of work. You then get into the idea of bifocals, where you've got lenses for looking far away and also close up to help your eyes adjust to the different type of image that you happen to be looking at. Now, another form that has become quite apparent is surgery. Now, I've just downloaded this image from LASIK surgery, and in this case, what they use is a laser, and they shave off a portion of the cornea. Now, remember I said to you the cornea is a clear protective layer which looks after your eye, but it also does some refraction. Now, up to a degree, we can shave off some of that cornea, which allows us to change the amount of refraction which is occurring by that cornea on the eye, and as a result, it can actually pull your lenses back in. Obviously, it can only be used if you've got very severe eye problems. Then obviously the shaving of those thin layers of cornea will not be enough to actually change your eyesight. So as a result, glasses often are worn. Okay, well, I hope that's given you an insight into, if you pardon the pun, into the eye and corrective measures that optometrists use to actually correct eye problems. And I look forward to you joining me again. Thank you for watching.